Hi, bright students. We meet again in the chemistry problem discussion on the Engineer Squad channel. In this video, we will practice problems in air requirement for combustion. In the complete combustion of 1 liter of acetylene gas with chemical formula C₂H₂, how much air is required? Note that air contains 20% oxygen and a chemical process occurs at constant pressure and temperature. To solve this problem, we need to write the combustion equation for acetylene. This step is to determine the coefficient of oxygen that reacts in the combustion process. Acetylene, C₂H₂, react with oxygen, O2, to form CO2 and H2O. We need to balance this chemical reaction by checking the number of atoms on both sides. First, we will check the carbon atoms. On the left side, there are 2 carbon atoms, and on the right side, there is 1 carbon atom. Thus, we need to multiply CO2 by 2 to equalize the number. Next, we will check the hydrogen atoms. On the left side, the number is 2, and on the right side, the amount is also 2. Therefore, we do not need to change its coefficient. Finally, we check the oxygen atoms. On the left side, we have 2 atoms, while on the right side, we have 2 times 2 from CO2 and have 1 from H2O. Thus, the total atoms on the right side is 5 oxygen atoms. To make it equal, we need to add 5/2 as a coefficient of O2. And now, the chemical equation is already balanced. We need to multiply everything by 2. It becomes 2C₂H₂, 5O2, 4CO2, and 2H2O. Next, we write down the volume given in the problem. The volume of acetylene is 1 liter. Meanwhile, the volume of oxygen is unknown. We can find the volume of oxygen by recalling the law of volume ratios. According to Gay Lussac, the volumes of reacting gases and the volumes of the resulting gases are proportional to their reaction coefficients. Thus, the ratio of the volume of C₂H₂ to the volume of oxygen is 2 to 5. Since the volume of C₂H₂ is 1 liter, the volume of O2 is 5 divided by 2 and multiplied by 1 liter, resulting 2.5 liters. Now, here we must be careful. This calculated value of 2.5 liters is the volume of O2, not the volume of air being asked in a problem. Before we continue, please don't forget to like this video and support us by subscribing to the Engineer Squad channel. Your support is meaningful for the sustainability of our channel and ensure us to continue in learning science together. Thanks for your support. Now, let's continue in solving this problem. To calculate the volume of air, we compare the volume composition of oxygen to air, which is 2 to 10. We find that the required volume of air is 10 divided by 2 and multiplied by 2.5 liters, which results in 12.5 liters. So, the volume of air needed for a complete reaction with is 12.5 liters. That concludes this problem of calculating the air requirement for a combustion. Thank you for diligently practicing chemistry problems. We hope you learned something in this video, and see you in another problem discussion video.